Okay, only two more to go. Gauss-Markov assumption number 8. The expected error for each predictor is 0. In order to understand this, just go back to really simple ideas that I've talked about in previous classes. So I'm going to start with creating two variables, x1 and x2. They're both random normal, and then create a y that's based on x1 and x2, and then add some noise. Okay, now before I get to these models, remember all of this, like the expected error, expected is a statistical term. And remember, stats is just like Spanish. It's a language. So once you learn what these terms mean, it's really easy to convert them over and to understand what's happening. So the expected values come from some form of statistical parameter estimation. Okay, for univariate or single variable analyses, the expected value is the mean, and then the expected residual, right? So remember what a residual is. A residual is y minus y hat, right? Now, when it comes to a single variable, we usually just label a variable x, and if the expected value for x is going to be the mean, then we know that the mean of the residuals is going to be 0. Now, we know that from a univariate standpoint, and we know it from a multivariate or bivariate and beyond. And so the expected values, or our parameter estimates, for univariate it's the mean, and for bivariate analysis and beyond, it's our regression parameters. Now, ordinary least squares is a process by which, it's an algorithm that minimizes the squared deviations, right? By minimizing the squared deviations, it by definition will produce a result that minimizes the mean deviation and will always produce a mean deviation of 0. So in other words, our expected residual is 0. Now, just to show you how that works out, is I'm running my model. I've got 3 models where I created my 2 variables, my 2 predictors, x1 and x2, and then I have a y. So I create 3 linear models. The first one just has x1, second one just has x2, and the third one has x1 and x2. And then I just rounded the mean residual, because if I don't round them, it has a scientific notation, and it was something like 5 times 10 to the minus 17th. I've got it somewhere up here. I'll show you. It's pretty ugly. So I tried to make it easier for you. Yeah, so it's minus 3.59 times 10 to the minus 19th. That's 0 in my book. And after we round it, it's 0 in my stats package book as well. See? I rounded to 2 significant digits. It's 0. So this assumption is, and this applies to ordinary least squares regression, that the expected error for each predictor is 0, and the expected residual really is 0. Okay? You will test this by looking at regression diagnostics, and I can show you what that amounts to is if I do a plot. Oh, remember, I have this new quick little function that puts them all in a single figure. There we go. And all it's saying is that this line, so there's a little dashed line right there, that we expect the mean residual to fall along that line. And when there's a little deviation, oftentimes that deviation is going to be due to a variety of things. It's going to be due to outlier, like maybe this outlier is really influencing everything. But overall, the line of best fit is going to be through all these data points. These are residuals, is going to be 0. Okay, so that's the second to last assumption. The last assumption I'm going to cover in the next video. So stay tuned.